Hello, my name is Charles Porter and this is 2.3 Fatigue and Recovery. So what is fatigue and what is recovery? So fatigue is basically the extreme tiredness of the muscles resulting in physical exertion. Recovery is how the body returns back to its normal resting state. So today I'm going to be looking at fatigue in this video. So what is fatigue? So I said in the previous slide that fatigue is mainly physical. So in sport, we mainly have physical fatigue in different sports, but we can also have mental fatigue. Say after work, you've had a really stressful day at work. Your brain might be feeling really tired after working so hard. And this fatigue is a real problem for athletes, because it prevents them from doing well in their sports. It prevents them from a good performance. So basically, how is fatigue built up? So here you can see fatigue is mainly caused by a lack of PC. So this lack of PC then means the lack of glycogen. Lack of glycogen stores equals increase in lactic acid. This increase in lactic acid then increases CO2 as well. This produces more heat then, and then calcium levels then decline, meaning that the muscles can't contract to their full ability, so they can't contract strongly, and this causes fatigue. So depletion of energy sources. In our body it is vital that we have a constant supply of energy sources so that our body can function properly in exercise and at rest. So creatine, so in other words PC. So this is the energy system used after ATP. ATP is the energy system used at the beginning of exercise, and then after ATP has been used up, the PC energy system then takes place. So athletes use PC quite a lot. So they use creatine supplementation. This is when athletes take on more PC, more creatine, basically to give them more PC, so that after ATP has been used up, they can use PC for a longer period of time and not for a short period of time. However, there are some side effects. For example, this could actually cause even worse levels of fatigue, and it can also end up in your urine, and also it increases in muscle cramping and nausea after an event. Also, our power reduces. So as we can see here, from this data we took from Eastbourne, as basically time goes on, and the power basically decreases in exercise. So here we can see how its power levels are really high. This will probably be where his ATP system is being used, and then towards the middle here we can see an increase in power again. This will probably be his PC system, as ATP system has been used up, and then it slowly decreases and decreases. An example would be a 200 meter sprint. So at the start here, this will probably be the 100 meters part, and then so that will be where your ATP system will be being used, and then towards the end, the second half, this will be where your PC system is taking over, and that's the last final sprint. So now moving on to glucose and glycogen. So a decrease in glucose and glycogen is very bad, as they are vital in the lactic acid system. So these two things are basically found in carbohydrates. So carbohydrates like pasta, for example, in foods. These carbohydrates are then taken into the body and they're turned into glucose. Glucose are then broken up by glycogen phosphorylase, or GPP, and this then the breakup then forms glycogen. So glucose is then broken up by glycogen phosphorylase and is turned into glycogen. A lack of carbohydrates equals a lack of glucose and glycogen, obviously, as carbohydrates form glucose and then glucose gets turned into glycogen. So in other words, carbohydrates is actually a form of energy, because this is where we actually get energy from. This also prevents pyruvic acid if we don't have enough glycogen and glucose. So basically, more carbs equals less lactic acid, which means less levels of fatigue. So if we don't take on a lot of carbohydrates, then there's a lot larger buildup of lactic acid. So effects of waste products. When we use our energy systems, we produce a couple of waste products which are mostly unharmful and get breathed out. So the first one is CO2. So this is an unharmful one, because people see it as harmful as CO2, and CO2 affects climate change and so on. But CO2 in our bodies it's not very harmful because we're actually breathing it out. So it's produced in the muscles during exercise, and it might also be produced at rest, slightly, like very small levels. But during exercise, our muscles release CO2 into the blood, so it's diffused into the blood. So 3% goes into the plasma in the blood, 23% goes into this hemoglobin called carbaminohemoglobin. This basically does the same as hemoglobin, but instead of carrying oxygen, it carries carbon dioxide. This then carries the carbon dioxide through the blood, and they take it to the lungs where it's then breathed out. And then 70% of the carbon dioxide is resultant in carbonic acid. CO2 is then sent to the lungs, as I said, with the hemoglobin. But also we struggle with sometimes when we struggle with breathing, this can be due to waste products being built up in the lungs. So, for example, CO2. If there's too much CO2 in our lungs, we may find it quite hard to breathe it out. And this could be an effect from being wounded. So now moving on to lactic acid. So basically, lactic acid, this is the leading cause of fatigue. So during exercise, when we exercise, as time increases, so does our lactic acid. So it's mainly produced in anaerobic exercise. So in like a 100-meter sprint, for example, so after the 100-meter sprint, you'd have a massive increase of lactic acid. Also, as intensity increases, so does lactic acid buildup. So basically, more weights being put on basically leads to an increase in lactic acid. So here we can see from the graph, this is called hitting the wall. So as we can see here, as the running speed increases, our VO2 increases as well. So basically, this is the intensity. So as the intensity increases, here we can see a rapid increase in our VO2 levels. So basically, this means the amount of oxygen we're taking on board. So what this also tells us is that our muscles are requiring more and more oxygen as the speeds are increasing. As our muscles are requiring more oxygen, this means that they're working harder, which means that lactic acid will build up. So as I put here, as speed increases, so does VO2. This VO2 increase then results in an increase of lactic acid, and then lactic acid can cause fatigue. So now we have heat. So with heat, 20% of oxygen is used, and the rest is heat. So basically, the oxygen that we inhale, 20% of it is actually being used, and the rest of 80% of the oxygen being inhaled is basically turned into heat. So here you've got hypothermia. So basically, this is during exercise, or even not during exercise. This is an increase in core body temperature. The increase in core body temperature is then very dangerous, and it can cause death and really bad illnesses. So it's important that we keep a good core body temperature, and we do this by having a lot of water and keeping our body hydrated. This then affects performance. So having a lot of heat in your body definitely affects your performance. I mean, it's good for your muscles having some heat, as they can work better. But during performance, as your core body temperature is really hot, it's very hard to breathe sometimes. So a lot of athletes use this method called heat acclimatization. So this is basically using your environment around you and the temperature around you to enhance your performance. So a lot of athletes will go to, say, English athletes, as the temperature around here isn't amazing. So they would go to other countries, say like Spain, for example, in the Middle East, to train, and they'll go to high altitudes to train. This will basically get their body used to training in hot climates, so that when they come back to the UK, their body should react fairly easy to the climate around it. So pre-cooling, this is used before exercise, and it basically allows the blood flow back to the muscles. So you see a lot of football players and a lot of key athletes, they use ice baths basically before and after an event. This therefore gets all the blood from your stomach, and it goes to the key muscles that require it, and it therefore aids performance as the muscles have the oxygen they need. And then we have basically fluid ingestion. So basically it's really important that we inhale a lot of fluids during, before, and even after exercise, and as it basically increases heat storage capacity, and it just makes the body flow a lot better and work better. So now moving on to neuromuscular fatigue. So here we have the depletion of acetylcholine. So basically, acetylcholine is vital with nerve impulses. So, and it works around an all or nothing law. So basically, as the acetylcholine reaches just before the synapse, it has to have a very good amount of it for it to then travel across the synapse. So if there's not enough acetylcholine, then the acetylcholine will not be sent across the synapse. So we need to have that good supply of acetylcholine so it can be sent over. So here we have the synaptic cleft. So basically, this is where the acetylcholine has been sent over. As the acetylcholine has been sent over, cholinesterase, I think that's how you say it, that's then used to basically get rid of the acetylcholine. If there is not enough cholinesterase, there you go, then this basically prevents the acetylcholine from being removed. As the acetylcholine is not being removed, then the acetylcholine that's basically stored up before the synapse then can't be sent over as it hasn't been cleared from the synaptic cleft. So this then causes fatigue as the muscles do not receive the right nerve impulses to contract. Here we have calcium ion release. So reducing calcium ion release is very bad, as calcium is vital in muscle contraction. So here, as we can see from the picture, calcium ions are released here, and this basically causes the muscle filament to then contract. During the relaxed stage, our calcium is then inhaled, and it's basically has this closed channel, so no calcium can escape. The calcium that does escape then causes the muscles to be tired, and it doesn't allow them to have a very strong contraction. So as I put here, the calcium that is leaked, it reduces the muscle contraction, strength of that muscle contraction. So it's very important that we have a good supply of calcium, because a lack of calcium then reduces the strength of the muscle contraction.